Hi, welcome back. In this video, we're continuing to look at graphing exponential functions. We're going to talk about the general parent function right now for y is equal to b to the x. For these functions, for the general parent function, b is a positive number. So b is greater than 0 and not equal to 1 for all of these. If b is a positive number, we are going to have the same asymptote for all of these. And when we draw an asymptote, we're actually going to draw it as a dashed line. In this case, it's through the axis, so it's a little difficult to see. But we are going to have an asymptote of y is equal to 0. That means this graph is going to approach but not cross that asymptote. So we are going to consider 3 values of x for all of these graphs. So 3 values for this exponent. So that is going to be -1, 0, and 1. These are going to give us kind of the understanding of what's happening. So b to the 0 is always equal to 1. And then we have b to the 1, which is just equal to b, and b to the -1, which is 1 over b. The way this looks on our graph over here is going to depend on the value of b. So let's first talk exponential growth. Exponential growth occurs when b is greater than 1. So if b is bigger than 1, we're going to have this point here that will be 0, 1. The point to the right at an x value of 1 will have 0b, which will be a number bigger than 1 up here, and 1 over b will be a number smaller than 1 over here. So our graph will look like this. And this is exponential growth. For the same set of points, so again, this is 0b this is positive 1b, and this is -1, 1 over b. When we look at exponential decay is going to have a value for b between 0 and 1. So 0, 1 will still be at the same place, but -1b will now be bigger than 1, and 1b will be less than 1. And our graph will look like this. This is decay. So you'll notice that growth and decay are mirror opposites of each other, and we use the same 3 points. So those points are -1, 1 over b, 0, 1, and 1b as our parent function. So keeping this in mind, let's actually talk about transformations to the parent function. So looking at our equation here, we have y is equal to a times b to the x minus h plus k. So a here is going to be a multiplier multiplied by this exponential piece. A is going to be a vertical stretch or shrink. And if a is less than 0, this is going to flip our graph across the x-axis. So that would mean we would have a graph that looks like this or like this. So this would be a is less than 0 and an exponential growth. And this would be a is less than 0 and an exponential decay. So we'll kind of look at what that actually ends up looking like, but this is going to be vertical stretch or shrink and a flip across the x-axis. If we are looking at this value h, you'll notice it's x minus h, so you're going to take the opposite of that. And that is going to be a horizontal shift. So that's going to move our graph left and right. And this value of k is going to be a vertical shift. So these are going to do the same thing that they have done in the past, just with our different parent function here. In our next video, we'll look at some examples of how we actually graph these.